All right, here is the final exam review for pages 9 and 10. So starting with 46, for the function y is equal to 5 raised to the x minus 2, identify the transformation from the parent function. So remember, transformations work the same for all functions. What's added with your x values is your shift left and right, and you always go opposite. And then anything added on the outside, so anything added on the outside, so just added on the outside, is your shift up and down, and your sign stays the same. And our sign stays the same. So if we look at this function here, we have negative 2 being added, so we have x minus 2, so we're subtracting 2 from x. So it's being added with our x, so that's our shift left and right. We always go the opposite, so it's being shifted right too. And that's all we had to answer on that one. So if I would have had this, y is equal to 5 raised to the x minus 2 plus 3, then it also would have been going, so it would have been going right 2 and then also up 3. So that was just another example. Write each equation in logarithmic form. So the first thing we have to identify is the base. So we're rewriting these exponentials in logarithmic form. So we have to identify the base. Now the base is the part being raised to the power. So in this, these are the bases here. So we have to take log to that base of both sides. So I take log to the base 8, and you have to do it to both sides. So on the left, I have log to the base 8 of 64 is equal to, and then don't forget that log to the base 8 and base 8 are inverses of each other, so they cancel out, so that 2 drops down. This is rewriting it in logarithmic form. So over here, once again, the first thing is identifying your base. It's base 3. So we have to undo base 3. The only way to do that is log to the base 3. So over here on the left, I have log to the base 3 of 729 is equal to, those cancel out, and our 6 drops down. Okay, graph each function, then find the domain and range and the y-intercept. So if we graph this, we can definitely use our graphing calculator, but also I want you to at least draw in your asymptotes. So there's no shift left and right, but we're shifting down 2, so down 2. And with, these are exponential functions. With exponential functions, there's only a horizontal asymptote. So we have an asymptote at negative 2. And if you graph it in your graphing calculator, then you can see what it looks like. So it looks like this. It's going like this. So a rough sketch is good enough. And now we'll identify our domain and range. So domain is x values. So where is it growing from left to right? It's growing from negative infinity to positive infinity, left and right. Then our range is our y value. So how far down does it reach? Well, it reaches down, really it approaches that asymptote. It never crosses it, but it's getting really close to negative 2. And then it's growing upwards, it looks like, to positive infinity. Now, because it didn't touch down on negative 2, because it never crosses it, we've got to put a parenthesis and not a bracket. So that's how we would do our domain and range. So on this next one, once again, there's no shift left and right, and there's no shift up and down. So our asymptote is just at this horizontal line, which is y is equal to 0. So then from there we can graph it, type it into your calculator, and it looks something like this. So it looks like this. And then we'll do our domain and range. So domain is left and right. It's growing from negative infinity to positive infinity on our x values. Our y values, which is our range, it's getting really close to 0 on our y values, and it's growing to positive infinity. Once again, it never crosses the asymptote, so we need to put a parenthesis on that. Evaluate each logarithm. So there's no way to calculate this using your calculator without using the change of base formula, because your calculator doesn't know how to type in base 3. So we use the change of base formula. So we do log of 243 divided by log of 3, and now it's in base 10. You simply type it into your calculator, and if you do, you're going to get 5. So the same thing here. We have log of 625. I use the change of base formula divided by log of 5. If you type that into your calculator, you get 4. Okay, so a classmate says that y is equal to 3 over 2 raised to the x represents exponential decay. What's the mistake? So remember that exponentials have the form a times b raised to the x. B is what you know if you have, is what you use to know if you have growth or decay. So it's growth if b is greater than 1. It's decay if b is less than 1. So 3/2 is a fraction, but if you actually want to know the decimal amount of that, you'll do 3 divided by 2, and you get 1.5. So technically we have y is equal to 1.5 raised to the x. Now our a value on this one is 1. There's always a 1 written there. But we look at our b value to see if it's growth or decay. So notice 1.5 is greater than 1, so our b value, 1.5, is greater than 1. So it's got to be growth. So that's why your classmate was mistaken, is because b, even though it's a fraction that still equals 1.5, which is greater than 1. Find the value of log the base 8 of 64 without a calculator. So if we were able to use our calculator, this is how I do it. Log of 64 divided by log of 8. You get 2. But you had to have a calculator to do it that way. So I'm going to now do it without a calculator. So if we have no idea what log of the base 8 of 64 is equal to, we'll say it's equal to x, because we don't know what it's equal to. Well, now I can rewrite that as an exponential. To undo log to the base 8, I take base 8 of both sides. Now log to the base 8 and base 8 cancel out. We have 64 is equal to 8 to the x power. So then just think about it. What value of x makes this a true statement? Well, isn't it 8 squared? Isn't 8 squared equal to 64? Yes. So x is equal to 2. So that's why x is equal to 2. So you could always use this way to check it using your calculator. And I use this way if it doesn't specify if I need to use my calculator or not. I just use the change of base formula because it's easiest for me. But you could do it this way. And they just want to know you know how to do it both ways on this problem. Solve each equation, and then it does say, and I didn't catch this till just barely, it says, and round to 2 decimal places. Okay, so notice we have ln of 3x is equal to 8. So we're solving an ln equation. ln's are logs, they're just natural logs. So your first step with solving a logarithm is make sure there's only one log, or make sure that there's one log on each side of the equation. So isolate that log completely, nothing added to it, nothing being multiplied to the log. So ln is all by itself. Nothing is being multiplied to ln, nothing's being added to ln. So now we can undo ln. And what does ln? It's e. So if we do e to one side, we've got to do it to both sides. So ln and e cancel out. So left is 3x, which is equal to e to the 8th power. And then from there, we're just solving for x algebraically, divide both sides by 3. So we get x is equal to e to the 8th divided by 3. Now that answer is very pretty. It's exact. So I don't know why they'd want us to do the decimal answer in this one, because really that's a prettier answer. But I'm going to go with the instructions. So it says round to 2 decimal places. So I'm going to type it into my calculator. E to the 8th, and then I hit divided by 3. And I get 993.65. That's where I would round it correctly. So I guess in this problem, this is technically the right answer. I like this answer much better. In fact, I think on an actual end of level or ACT, this is the answer they would prefer. But you never know, so I'm going to go with the directions. So in this next one, once again, nothing added to your ln, nothing multiplied to it. So we've got to isolate the ln. This one's isolated. So now we undo ln. So we're going to undo ln by base e. Base e and ln cancel out, leaving us with x minus 4 is equal to e squared. Then from there, we're just solving for x algebraically, so I'm going to add 4 to both sides. So we have x is equal to e squared plus 4. I like that answer. It's much prettier than the decimal, but like I said, I'm going with the instructions. E squared plus 4, I hit enter, and you get x is equal to 11.39 if we were to round correctly. So I'm just going to go with the instructions on this one, but I do like the e answer better. Rewrite each expression as a single logarithm. So we have to know properties of logs. So when you add, you multiply. So we're rewriting this as one log. So it's 2 separate logs. We're rewriting it as one log using properties of logs. So that's going to be log to the base 5 of 3 times 6, which is log to the base 5 of 18. This is rewriting it as one log. You could stop there. With this one, the first thing we need to take care of is this, what's being multiplied is always an exponent. So you've got to take care of that first. So I have log to the base 4 of 25 raised to the 1/2 power plus log to the base 4 of 2. And now now that I fixed the powers, I can rewrite it as 1 log. So now because of that plus sign, we're multiplying that but rewriting it as 1 log. So we have log to the base 4 of 25 raised to the 1/2 times by 2. And so that's log to the base 4 of 25 raised to the 1/2 is technically the square root of 25, which is 5. But you could just type in your calculator 25 raised to the 1/2 power, hit enter, then times 2. So we have log to the base 4 of 10. Solve each equation. And so what we're looking at, every equation is different, but if you look at this first one, it's an exponential equation. So our first step is to isolate the base. Our base is isolated, nothing multiplied to it, nothing added to it. So now we have to undo base 9. The only way to do that is log of the base 9. So we've got to do it to both sides. So now, because we have base 9 and log of the base 9, those do cancel out. They're inverses of each other, so y minus 3 is equal to log of the base 9 of 81. And then this side can be calculated, but we'd have to use the change of base formula, which is log of the big thing, log of 81, big in size, divided by log of 9. So now from there, we're just going to solve for y piece by piece. So I'm going to add 3, add 3. Make sure you don't add 3 into the logs. That would not be correct. So you'll actually have log of 81 divided by log of 9, and then plus 3. So you got to type it in as such. And if you type it in correctly, which you should practice typing it in, you type in log of 81 divided by log of 9, hit enter, plus 3, and you would get 50. Okay, I got 5. So you get y is equal to 5. All right, on this next one, a lot of people confuse that 1/3 of being a base, but it's not. Log of 1/3 of x is equal to 2, so we're solving a logarithmic equation here. We have to isolate the log completely. Nothing multiplied to the log, nothing added to the log, but it's isolated. Now we have to undo log to the base whatever. Well, remember that if there's nothing written there as a base, technically there's a base 10 written there. So how do we do log the base 10? How do we undo it? Well, we take base 10 of both sides. So then I have 1/3 x, because base 10 and log of the base 10 cancel out, is equal to 10 squared. So what we really have is 1/3 x is equal to 100. Now to get rid of that 1/3, we're going to multiply both sides by 3. Because what undoes 1/3? It's 3. 3, so we got to multiply 3 to both sides. Now, why does 3 undo 1/3? Because 3 times 1/3 is 1. So we have 1x is equal to 300. Well, now isn't x alone? Well, we could divide by 1. So x is equal to 300. And you could even check this one. Type it back into the original problem. So you'll type it into your calculator, log of 1/3 times 300. So since that didn't have a base, it had base 10, we could actually check this one really easily. So you could just type it in, log of 1/3 times 300. Hit enter and you will get 2. So x is equal to 300. Okay, expand each logarithm. That means we have it written as one logarithm. We're going to break it apart and rewrite it as 2 different logarithms. So the first thing I do on this one is I know that if we have a radical, that's the same thing as a rational exponent. So we have x times y to the 1/3 power. Roots go on bottom. If you remember your picture of your flower, roots go on bottom, power goes on top with like the power of a flower. So that's why it's a 1/3 is there was technically a 1 right here, y to the first power. So the power goes on top, the root goes on bottom. So this is really what we have. And now we can rewrite it as 2 logarithms. So we have log to the base 5 of x. And since we're multiplying, we're going to add, but make sure you add that log to the base 5 of y to the 1/3. And then it's not considered simplified unless you have the exponents pulled down in front here. So our final answer will be log to the base 5 of x plus 1/3 log to the base 5 of y. This is the expanded version of this. Okay, so we have log to the base 3 of x to the 4th divided by y squared. So we're trying to rewrite this as many different logs. So we have log to the base 3 of x to the 4th, and because we're dividing, we subtract. So subtract log to the base 3. Don't forget the log to the base 3 part, that's very important. Y squared. Then we fix our exponents, pull them down in front. So our final answer will be 4 log to the base 3 of x minus 2 log to the base 3 of y. And this is the expanded logarithm. Alright, so write log of 27 as the sum or difference of two different logs. So I just said, okay, so as the sum or difference of two logs. So to be able to do sum, we're going to have two things being multiplied, because when you multiply, you add. So two things that multiply to be 27, 9 times 3. So I'm rewriting this as log of 9 times 3. Well, we could split this up as two logarithms, because we know when you multiply, you add. So we have log of 9, technically, plus log of 3. I'm just expanding that logarithm. And that is log of 27. That is your answer. Now you could, like I said, you could check it by going backwards. So if we wanted to rewrite this as one log, we'd be doing log of 9 times 3, because when you add, you multiply, which is equal to log of 27. So hopefully that helps you see where we are coming from with this one. And that's the end of the review. Thank you for watching the video, and come ready for this final exam.